Hello dear students, a very warm welcome to Alan Digital. In today's lecture, we are going to study some important concepts regarding area under curve. You know, it's a very important chapter as far as JEE Mains and JEE Advanced as considered beta. Right. Under this chapter, we are going to study a very important article which is remembering some standard areas. Okay. Sometimes if these standard curves comes in the examination directly, you can actually use these formulas to save your time in your examination paper, right? Because you know na, saving time is very much important. So we can actually use these particular set of formulas to save our time if the question is coming from the standard curves part like parabola, ellipse, hyperbola, these kind of things. Okay, so let us see which curves we are taking over here. Article is standard areas to be remembered, and you know there are lots of questions coming in JEE Mains as well as in advanced beta which includes standard curves, and sometimes area between their standard curves are also asked, right? So we are moving in that direction, and some standard curves I am discussing over here. First is area bounded by parabolas. You know, standard parabolas, there can be two parabolas. One is like of the equation y square equals to 4ax, and other one is x square equals to 4by. It's like you already know how to plot these parabolas. You already know the terminology of these parabolas, right? So we are interested in finding the area between these two parabolas. You know, x square equals to 4by is this, which is symmetrical with respect to y-axis beta, and y square equals to 4ax is this, which is symmetrical with respect to x-axis. We can easily plot that. Now, if we are talking about the area between these two parabolas, clearly you can see beta, they are intersecting over at the origin. I can prove that too. While deriving the formula, I will prove that they are intersecting at origin and at a certain point which is lying in the first quadrant, right? So the area bounded by these curves you can see is this beta. Bounded area, we always calculate the area as a bounded region, right? So this is the region you see, both the curves are bounding over there, and I can shade that region for you. And let us see beta, these curves are intersecting at a certain point. I have assumed to be abscissa of that particular point as k beta. X coordinate I have assumed to be k. We can actually find the value of k. Hence, we can see that what can be the area. I have the formula over here, that finally our formula comes out to be, which is very easy to remember. It is beta, this particular shaded area between x square equals to 4by, x square equals to 4by and y square equals to 4ax comes out to be beta 16ab upon 3. Mod we have placed because we know beta, area is never negative, right? Area is always positive. That is why we have placed mod over here, and the formula comes out to be 16ab by 3. In other words, you can remember this formula like I am writing this as beta 4a into 4b by 3, and you know 4a is nothing but your latest rectum, and 4b is also your latest rectum. I am assuming this as LR1, latest rectum 1, latest rectum 2, and you know the formula is now the product of latest rectums divided by beta 3. Okay. So in another words, you can remember this formula. Formula is very important. It will save your time because you will be seeing that if you are going to like derive the formula, na, it will take some time. But if you remember the formula as it is, it will, you will take less time, I can say, right? You will take less time and you will save your time so that you can use your time in some other hard questions or some calculative questions, right? Okay. So now let us prove that. We need to prove this formula. I am going in that direction beta. Prove. First of all, I am writing the expression of the area that we need to calculate. And we know beta, whenever there are two curves intersecting, the area is always written as, if we are writing with respect to x-axis beta, the area is always written as upper curve minus lower curve, right? You know this formula, right? So I am writing the area of SR means beta shaded region, that region which is shaded over there. Area of shaded region comes out to be, see, integration of 0 to k. Now I have placed limits of x over here. So here I will be integrating with respect to x obviously. Right beta? So integration 0 to k, I don't know the value of k, we can calculate that later on. First of all, I am writing the expression. Now the upper curve is beta, you see, this is the red one is your upper curve, which is y square equals to 4ax. But we will write the value of x, right? We will write the value y in terms of x, that is y square over there. If I take square root over there, so it becomes beta 2 root of ax minus, this is your first curve, 2 root ax, I have taken square root. And the second curve is beta, that is downwards, which is x square equals to 4by. Again, if you can calculate y from here, it comes out to be minus of x square upon 4b, and we are beta integrating with respect to dx obviously, right? Okay, so now this is your area of shaded region, and for this, for calculating this beta, we need the value of k. So I am doing some calculations first for k beta. I am finding the value of k in terms of, obviously your final area comes out in final area, you can see now, that is in terms of beta ab. So obviously we have to find a relation between k and ab, and let's see what we have. You know, the k is a point which is lying on both the curves, so it must satisfy both the curves, right? Okay, so in the first curve, instead of x square, I am writing beta k square is equals to 4by. From here, you can write the value of y is equals to k square upon 4b beta, right? In the second curve also, you can see y square is equals to 4a, and instead of x, I am writing k over here. Now, you know, two equations are there in y. This equation and this equation, we can directly eliminate y, and there will be equation consisting of a, b and k. We can easily solve that. You know, from here, I am calculating beta y square. That comes out to be k power 4 upon 16b square. It's very easy, right? And now you have y square from here also. Let us say this is your equation number 1. This is your equation number 2 beta. You can easily write from equation 1 and 2, equating both the equations, I am having beta, see, k power 4 upon 16b square is equals to 4ak. That can be again written as k power 4 is equals to, I am multiplying this over here, so 64 beta ab square k. Now from here you can easily take all the terms one side, and you can write from here beta, I am taking k as common, k cube minus 64 ab square is equals to 0. You see beta, we have two values of k, which is first is k equals to 0, and I told you when I was proving, I will show you that the second point of intersection comes out to be origin. If your k is 0, if you substitute your k over here, your y is also comes out to be 0. So one point of intersection is surely beta origin, right? And the other one is from here, if I equate to be 0, that is like k cube. So the value comes out to be k is equals to 64 power 1 by 3 is 4. And then we have ab square power 1 by 3 like this. This is the second value of k. You can say that is the particular x coordinate of this point of intersection. So this is the value of k beta. First we have found the value of k. Now what we are going to do? We are going to substitute this value of k over here, and then we are going to integrate that and find the area of the expression of the area beta. Right? Okay. So I am moving in that particular direction. Let us see. We were proof again. You know, now area of shaded region, I can write as area of shaded region beta. Now I can write as integration 0 to k. And you know, from here the value of k comes out to be 4ab square power 1 by 3. Right? So 4ab square power 1 by 3 to root a root x minus 1 by 4b into x square, and we are integrating with respect to dx. Simple integrations are there. Just integrate and see, you will match this result. So area of shaded region we are chasing beta, and see Here 2 root a is your constant, so we can keep that out. I am integrating root x with respect to dx. You know, beta, it's easy integration. Root x. Root x means x power 1 by 2. And whenever you have x power n, the integration comes out to be x power n plus 1 upon n plus 1. So 1 by 2 plus 1 upon 1 by 2 plus 1. Directly I am writing, beta, the integration comes out to be 2 by 3 x power 3 by 2. Minus, beta, there is 1 by 4b over here. And the integration of x square is very easy. X power 2 plus 1 upon 2 plus 1, that is 3. And we are integrating, see, our limits is 0 to beta 4ab square power 1 upon 3. These are our limits. Now clearly you can see, if you if you substitute upper limit over in the values of x, you will be getting some value that we can calculate. But when you are substituting the lower limit, due to this 0, this x would become 0, this x would become 0. So there will be no term of there will be no term if you substitute beta lower limit over there, right? So lower limit is not contributing to any calculations, so we can easily just remove that. And now area of shaded region, you can write it as beta. Now I am substituting, see, 2 root a into 2 by 3. Instead of x, I am substituting 4ab square power 1 by 3. So beta, it is like 4ab square power 1 by 3 whole power 3 by 2, if you can see over it, right? Now minus, beta, we have, see, this is 1 by 4b into 3, it is beta 1 by 12b. And instead of x cube, again I am writing 4ab square power 1 by 3 whole cube over here. Simple calculations, we know that this becomes beta 4 by 3 root a, and I am directly doing all the calculations. See beta, this is 4 by 3, we are good to go. This is 4 power 3 by 2. See, 4 power 3 by 2. Again beta, it can be written as 2 power 2, 3 by 2, 2 is getting cancelled. So ultimately the answer that I am getting as 8 from here, right? So this particular term 4 power 3 by 2 becomes 8. 8 4s are 32. So from here I am getting beta 32 by 3. Now see, root a is there and a power, this 3 is obviously getting cancelled. A power 1 by 2 I am getting from here. A power 1 by 2, that is again root a. So root a was there, and then again you are having root a. So here root a would become a, right? Into, see, b square power 1 by 3 power 3 by 2. 3 is getting cancelled, 2 is getting cancelled. Ultimately you are having beta ab from here. Minus, there is 1 by 12, but I can see that we have 4 cube, 4 power 3. So that would become beta 64 by 12, and then ab square power 1 by 3, and there is b also over here, right? We have 4b na beta, so 1b is also there. So I am placing that b over here, and here the 3 is getting cancelled, and I am getting beta ab square, and 1b is also getting cancelled. Ultimately I am dealing with, see, this is 16 and this is 3 beta, 4 16 4 3. So I am getting 32 by 3 times of AB minus 16 by 3 times of AB, which is nothing but 16 AB by 3. And for safer side, I have applied mod because, you know, area is never negative. So that is the proof of that particular formula, right? But again, if you are wasting your time in proving this, it just doesn't make any sense, right? In the examination, we have to save our time as much as we can. Okay, so either you can remember this formula as 16ab by 3, or you can remember as beta product of latest rectums divided by 3, right? Let us see 1-2 questions based on that. We have easy examples, and you can easily write the answer based on the formula. See first question. It is beta, parabolas are given y square equals to 4x and x square equals to 16y. Clearly you can see beta, lattice rectum 1 comes out to be 4 and lattice rectum 2 comes out to be 16. It's easy. So the area is again mod of product of lattice rectums divided by 3 beta. Answer comes out to be 64 by 3. It's very easy. Now if you are going to do those calculations, you are just wasting your time. That is why these standard formulas have to be remembered beta. They will save your time. right? In a flash, in a single step, you are writing the answer. Here also you can see beta, your latus rectum 1 is 1, latus rectum 2 is 1 beta again, and area is product of latus rectums divided by 3. Final answer comes out to be 1/3 in this particular case, right? So it's very good if you remember these formulas. That will save your examination time a lot, right? Okay, now just like this, one more set I am taking beta. Here I have taken parabola y square equals to 4x and the line y equals to mx, and you can see the diagram over here. We have this parabola and y equals to mx. You know, y equals to mx lines always passes through the origin. Mx means a family of lines which are passing through the origin beta, right? Now again the same thing we are going to do over here, that assume that point as k, okay, and then find the value of k, write the expression of the area, and then let's see what the formula is coming out to be. First of all, I am telling you the formula so that you will be more comfortable. Obviously we are talking about that particular shaded region beta, that is shaded over here, and the formula is 8a square upon 3m cube. This is the formula, right? Okay, so let's see if we can prove that very easily. Like we have, I am proving this. Okay beta, proof. Okay, so now we have, yes, let us say I am assuming this coordinate as beta, again x coordinate I am assuming as k, as simple as that, right? So area of shaded region, if I am going to write here, is 0 to k, upper curve is now beta 2 root a root x dx, minus lower curve is this straight line which is beta mx, and with respect to obviously dx, this is my shaded region. And now we are going to do some calculations for k, and to find k, obviously one equation you have as y square equals to 4ak beta, and the second equation you have y is equals to mk. If you club these two, if I am squaring this, so you are getting m square k square is equals to 4ak beta. From here, if you can take k common, then you are getting m square k minus 4a is equals to 0. Clearly from here you can say one point comes out to be k equals to 0. You can see at the origin they are intersecting, and other point comes out to beta k equals to 4a upon m square, right? This is the point of intersection. Now for me, the area becomes area of shaded region beta becomes 0 to 4a by m square 2 root a root x minus of mx, and then we have dx. Easily you know the integration of this, we have integrated that recently, right beta? So now what I am getting, see, 2 root a, and the integration of this comes out to be 2 by 3 x power 3 by 2 beta, minus integration comes out to be mx square by 2, and we are applying the limits from 0 to 4a by m is square. All the calculations are here in front of you. Easily manageable, and you can easily see that result after calculating. Again the same thing, if you are going to put x equals to 0 over here as a lower limit, every term is becoming 0, so we have no input of this particular lower term. We are just going to put the upper limit beta, that is 4 root a by 3 I am getting from here, and from here I am getting 4a by m square power 3 by 2 minus m by 2 was there, and 4a by m square whole square beta. That is my term. Now let's see what we are getting from here. Again 4 power 3 by 2, 2 power 2, it's 8, 8 4s are 32 I am getting from here. So 32 by 3 beta, and let's see what we are getting from here. Root a and a power 3 by 2. A power 3 by 2 is again a root a. So root a into root a would become a. One more a is there. So overall I am getting a square, right? So 32 by 3, here I am getting beta a square by m cube. Clearly you can see 2 and 2 is getting cancelled. M square power 3 by 2. So the 2 is getting cancelled. I am getting m cube beta. And minus, here if I do the calculations, clearly you can see this is m power 4. M square whole square, m power 4, 1m is getting cancelled. So from here I am getting 4 square, which is 16, that is 8, correct? a square upon m cube beta. If you take LCM na, you are getting 32a square minus 24a square upon 3m cube, which can be written as 32 minus 24 is 8a square by 3m cube, and for safer side I have placed mod over there, right? So you can match your formula 8a square upon 3m cube. Remember this formula, you are good to go, you are saving your time. Based on that, we are taking one question. Find the area bounded by y square equals to 8x and y equals to 2x. You are good to go. You know beta, if you are comparing with y square equals to 4ax, a comes out to be 2 beta. And from here, you can directly write m comes out to be 2. Now, area, if you remember the expression, it's very good. 8a square upon 3m cube beta. Okay, if you see the expression over there, 8a square upon 3m cube. Now I am placing the values 8 into 2 square upon 3 into 2 cube beta. Clearly 2 cube and 8 is getting cancelled. The answer comes out to be 4 by 3.